Hello guys, good evening. This is Mr. Abdurrahman Dawi with a quick video for you to revise before the exam. I'm not gonna have time to explain a lot of things today because it was a very big day for me, and I'm gonna talk about functions and also about what I requested. So first of all, I'm gonna talk about functions, and I'm gonna express few ideas for you so you try to follow up with me as quick as possible. We said that the function is written with this notation. Sometimes it's gonna ask you to find the function when the input is gonna be equal to 3. So as we said before, we said that the function is something that enters, and we don't know that function. We don't know what is it. And if he gave you the input, it means that he's gonna ask you for the output. And in this case, we're gonna use this example saying that the function of x is representing this is gonna be equal to 4x. So if I said that my function is equal to 4x, it means that the function when I have x as an input is equal to 3, it's gonna be equal to 4 multiplied by 3, which is equal to 12. So this is how you solve the function. Now sometimes it's gonna ask you to do something else, and before that we'll discuss it. I'm gonna change the color. If I said that I have another function g, and g is actually representing x squared, we will say you need to understand how to express function f(g(x) or g(f(x), the composite function, because they are totally two different things. When I tell you to do the f(g(x), it means that gx is going to be the input. Okay, so you're going to do the function gx is going to be equal to x squared, and this is going to be the new input. So function of gx is going to be equal to what? It's going to be the function of fx, which is 4, but instead of writing x, I'm going to write x squared. But if I say that I want g of x, means that I'm going to do fx first, and fx is equal to 4x. So this is the new input. So gx is going to be 4x, but it's going to be squared. So it means that's going to be equal to 16x squared. This is how you do g of x. Sometimes I'm going to ask you another thing. Maybe I will say solve fx. If I said solve fx, you'll say that fx. Sometimes I'm going to tell you this. Solve fx equal 12. When I say solve fx equal 12, it means you refer back to your fx, and you know that fx is equal to 4x, and all of that is equal to 12, so you say that x equal to 12 over 4, which is equal to 3. It means that x equal to 3, this is the solution for this function. Another thing that I might ask you, or I might bring it in the exam, saying the negative function. I said earlier that the gx is equal to x squared, right? Sometimes I ask you to find the inverse function of this one. So we said how we can find it by flipping everything. First of all, you need to express it as y equal x squared. After that, you're gonna flip x's with y's. And since y squared equals x, it means that y is going to be equal to the square root of x. So you say that negative, or the inverse function of g is going to be equal to square root of x. This is how we do it. Okay. Another thing, the request related to Ayn said that if we have a problem like this, and you're trying to find, let's say that this is expressing the, you say that it's expressing a speed of some sort. We'll say that it's a speed, for an example. This is speed, this is a graph, or speed time graph. Speed is that it's in meter per second, and this is time in seconds. Sometimes it's asking you to find the distance. Okay, and when you are asked to find the distance, you can try to find the area underneath the curve. And Ayn said that how we can do that. It's an estimation, and number one, sometimes the question is gonna say find the area using 5 slices. You'll say use, for example, 5 similar width slices. What is the meaning of that? It means that he wants you to calculate using this area using 5 slices. Think of them as a piece of paper that is gonna have the same width. So if I say that I'm gonna use the first slice here, you need to try to understand that you're trying to create as much as triangle as possible. And the other 4 slices, as you can see, they're gonna be in the shape of trapezium. The other 4, they're gonna start like this, and they're gonna end up as a trapezium like this. So try to be more precise with this. So you see how it goes. So it's it's an estimation. It's not a precise science. To try to do it as neat as you can. That missing part that you see, the area, the leftover area, it's not included as you have an estimation solution. So you try to do it with the ruler as best as you can, so you don't miss the slightest square of this tracing paper. And then you do it, as I say, like this. And remember, this is not a precise straight line, so it's going to be something like this. And you try to take your measurements. You know that each one of them has a width of 2. These slices, you know that this has a width of 2, 2, 2, 2, 2. So you try to find the area 1, area 2, area 3, area 4, area 5 by doing or applying your rule. Okay, so we will do it as quickly as possible. So the first area is a triangle. It means that's going to be half base of h, so it's going to be half multiplied in the base as 2, multiplied by the height. And from what I see here, it seems that it looks like 5.8, and you do your calculation, so it's going to be equal to 5.8 centimeter. We will call it, yeah, centimeter square. Area 2 is going to be an area of a trapezium. It means that you're going to do half of the summation of both of the half a plus b multiplied in h. So it's going to be equal to half as the summation of 2 bases. The first base here is going to be 8.5, but for this one it's going to be close to 7.6. So the area 2 is going to be half. You're going to add both of them, 5.8 plus 7.6 multiplied in h, and h is going to be 2. H is removing this one, so this is going to be equal to 5.8 plus 7.6, which is equal to 3.13 centimeter square. So you do that step by step until you find your answers. So now we're going to try to record these values inside of our drawing, so we don't, because we need to erase to make space. So for the first area 5, we're going to do it with the black, 5.8. For the second area, it's going to be close to, say, 13.3. Okay. Now we're going to erase area 1 and area 2 to do the rest of them, and we're going to do them quickly because the video has to be very short. And as you can see, you notice that from the equation, that when you do the equation of the trapezium line, 2 is removing h, so you end up by having a plus b. Okay, So all of it is just about adding the bases. So for the third one is going to be from where the other one left it. So A3 is going to be 7.6 plus what? Plus this one. This one is going to be 8.4. Yeah, it's going to be 8.4. Try to do it as a precise estimation as possible. This is 8 and this is 4. So it's going to be equal to 0.15. So this area is going to be 15. Area 4 is going to be equal to 8.4 plus, we will see, this is going to be close to this one. So it's going to be 1, 2, 4. It's going to be close to 9. So it's going to be equal to 17.4. And area 5 is going to be equal to 17.4 plus, we're going to see that it's almost, this one is going to be 9. So we'll say that this is equal, it has to be smaller by small fraction, so we'll say that this is equal to 8.8. So it's going to be 17.2. Why? Because here it's going to completely 9. So this is going to be 4.626. So this one's going to be 26.4. After that, you take the total of them, all of them, the total of areas, so you can find the total distance. And when you're going to use the calculator, I remember that the answer should be close to 51. So you're trying to add all of them to see if it's the same precision that I did before. 13.3 plus 15 plus 17.2 plus 26.4. So the area for all of them is going to be close to 77.7. It's an area, it's a total area, but don't forget that all of that area is referring to the distance. So we say that the total distance is close to this as meters, because this is the method of finding the total distance when you are dealing with speed time graph. You calculate the area using the basic 2D shapes rules, and you try to do it as neat as possible. I hope that this estimation was as precise and close to the real answer. You can take the graph and try to do it by yourself to see if the answer is as precise as my drawing, because I'm doing it with computer, so it's not going to be precise as a notebook. So that's it for now, guys. Take care and good night, and see you tomorrow on the exam. Try to use this video for as a quick revise, and see you tomorrow, inshallah. Take care.